Alright, so the last type of conic we're going to look at is a hyperbola. So we're going to look at a geometric definition of a hyperbola. So you'll see that ellipses and hyperbolas have similar equations, but they have completely different shapes. If you recall, the ellipse was using the sum of distances from two fixed foci, but for hyperbola, we're going to use the difference of distances between two foci. So a hyperbola happens when you cut a cone like this. So a hyperbola is going to have two pieces, which they're called two branches. Alright, so geometric definition of a hyperbola. A hyperbola is the set of all points in the plane such that the difference of those distances from two foci points F1 and F2 is a constant. So if you look at a point that is on the hyperbola, the difference between these two distances, the distance from the point to the first focus and from the point to the second focus, is going to stay the same. So any point on the hyperbola, if you calculate the difference between those two distances, it's the same number. So to obtain the equation of a hyperbola, we're going to look at a hyperbola where it's centered at the origin. Alright, so without no further ado, the equation of a hyperbola is just going to be x squared over a squared minus y squared over b squared equals 1, where c squared equals a squared plus b squared. So it's very similar to the ellipse had plus. So if you look at the graph of it, you can notice that we have two pieces, and there is symmetry with respect to the y-axis and symmetry with respect to the origin. So in this case, when the hyperbola is like this, we have no y-intercept, and then the x-intercepts, for example, let's find the x-intercepts, because clearly it has two x-intercepts. We set y equal to 0 in here, so it's just going to be x squared over a squared equals 1. Set y equal to 0. So then this is going to give us that x equals plus or minus a. So these are the x-intercepts. It happens at negative a and 0 and a positive a and 0. And these are called the vertices, actually. So the x-intercepts are the vertices. In this case, vertices of the hyperbola. And then the distance between the vertices is called the transverse axis. So the distance, this is called the transverse axis. And you notice that from here to here, this is a and this is negative a. The transverse axis is going to be 2 times the value of a. So 2 times a. So this is just some terminology that comes with the hyperbolas. So to put it all together, we're going to have we're going to have two types of parabolas. So when the vertices are on the x-axis, the x, so you have x squared plus over a squared minus y squared over b squared equals 1, where both a and b are positive numbers. Notice that the x is positive in here, the x squared, and the y is negative. So when the x squared term is positive, that's when you're going to have the foci and hence the vertices on the x-axis. So the parabola is going to have the two branches like this with the vertices on the x-axis. If you have that the x squared has the negative, hence the y squared has the positive term, you can also have a parabola with the vertices on the y-axis. Okay, so in this case, you're going to have that the y-intercepts are the vertices, and then there's no x-intercepts. Okay, so the vertices are either on the x-axis plus or minus a, or on the y-axis, and again, plus or minus a. The transverse axis, it's a horizontal distance when we have that the vertices are on the x-axis, and when the vertices are on the y-axis, it's a vertical, but its length is 2a in both cases. Then, just like rational functions that have asymptotes, and the asymptotes are the values that the function takes as x approaches a certain value, these hyperbolas are going to have asymptotes, and their equations are going to be plus or minus ba times x. So this is just the equation of a line, y equals mx plus b. So the asymptote, one of them is b over a times x. So that means that it's a line that goes through the origin and has slope b over a. So it's this one right here, for example. So this is the one of the asymptotes, is the line with slope b over a and x, and y-intercept 0, so it goes through the origin. And then the other asymptote is negative b over a times x. It's this one. So it's the line that also goes through the origin and has the slope, a negative slope, negative b over a. And then the foci happen at plus or minus c and 0. And then in the other case, the asymptotes, these are not vertical or horizontal, these are slant asymptotes. In the other case, the asymptotes are going to happen at a over b times x, so it's a line that goes through the origin and has slope a over b, and then the other horizontal asymptote is negative a over b times x. This box right here is called a central box, and you'll see that graphing it in the background, so the actual graph of the parabola is just the red portions, but these things, the asymptotes and the central box, are going to help us to draw the parabola exactly. So let's see how the central box is going to help us draw the parabola. Hyperbola. Alright, so first of all, we're going to sketch this central box. And the central box is just a rectangle centered at the origin. And it's going to have the corners at plus or minus a and plus or minus b. So that means that we need to know the value of a and the value of b. And once we have it, we're going to sketch the central box. And then we're going to sketch the asymptotes, which are just going to be the lines that extend from the diagonal of the central box. So once I have the central box, the asymptotes are going to be these lines that are diagonal extensions of diagonal of the box, and then the hyperbola is just going to be graphed like that. All right. So let's do an example. So you have a hyperbola that has the equation 16x squared minus 9y squared equals 144. We're asked to find the vertices, the foci, the length of the transverse axis, and asymptote, and sketch the graph. Okay, so recall that the equation of a hyperbola, it's either x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared. So we have the x squared and the y squared, and we have the minus. So the only thing that is bothering us right here, we need to have a equals to 1. So we're bringing the hyperbola and standard equation. So how can I make this 144 1? Well, I can divide both sides by 144. Okay, so I'm going to divide both sides by 144. And that's going to give me 16x squared over 144 minus 9y squared over 144 equals 1. So we have the equals 1 now. But still, we have to have it in the form x squared over a squared minus y squared over b squared equals 1. So I'm going to write this as x squared divided by 144 divided by 16 minus y squared over 144 divided by 9, right? Because I can move this down right here. Equals 1. And then I finally get that the equation is x squared over 144 divided by 9 is 16 minus y squared 144 divided by 16 is 9, sorry. This is 9. And then 144 divided by 9 is 16. Okay, so let me rewrite it again without the x squared over 9 minus y squared over 16 equals 1. So I know now this is the standard form of the hyperbola. So if I look in here, it's of this type because the x squared has the positive coefficient. So it's going to be with the vertices on the x-axis. So it's going to be looking like that, opening to the right and to the left. So I can even make a sketch in here that I'm dealing with a hyperbola like that. Okay, so then find the vertices. Well, the vertices are going to be on the x-axis, right? So it's the a value. So I can actually even furthermore write this as x squared over 3 squared minus y squared over 4 squared equals 1. So this is going to give me that a is 3 and b is 4, right? Because that's the equation. It's x squared over a squared minus y squared over b squared. So remember that a gives me the vertices. So the vertices are minus 3, 0 and 3, 0. They're going to be this value, minus 3 and 3. So we found the vertices. Let's find the foci. I don't even know if I'm saying that correct, foci. Okay, so the foci, again, they're going to be on the x-axis for this one. So they're going to be negative c and positive c. So negative c0 and c0. And I'm going to have to use the fact that c squared equals a squared plus b squared. So since c squared equals a squared plus b squared, I'm going to have that c squared equals a squared is 9 plus b squared is 16. So c is going to be 20 square root of 25. So it's going to be 5. We're looking at the positive one. So the foci are going to be, I'm going to write down below here. So the foci are negative 5, 0, and 5, 0. So we found the foci. What about the length of the transverse axis? Well, the length of the transverse axis, it's the horizontal distance between the vertices. So it's 2 times a. This is the formula for it. So this is just going to be 2 times a, which is a is 3. So it's going to be 6. Let's find the asymptotes and then sketch the graph. Now asymptotes. So the asymptotes are going to be the two lines plus or minus b over a times x. So y is plus or minus b over a times x. So I simply just have to substitute what b is. Well, b is 4 and a is 3. So these are the asymptotes. Okay, so to graph the hyperbola now, we're going to follow these steps. So we're going to sketch the central box first. So recall the center box is just the rectangle that goes through the origin, and it has the corner plus or minus a and plus or minus b. So the A is 3. So 1, 2, 3, 1, 2, 3. And then B is 4. So I'm going to have 1, 2, 3, 4, 1, 2, 3, 4. So I'm going to draw this rectangle. Which is the central box. This is 3, -3, 4, -4. And then I'm going to draw the horizontal asymptotes. And I don't even have to actually draw these lines. The horizontal asymptotes are just going to be the diagonals of this box. So you just draw the diagonals and then you extend them. Okay, so that is, we sketched the central box, we sketched the asymptotes. Now we're going to plot the vertices. So the vertices are -3, 0, and 3, 0. So this is one vertex, and then this is the other vertex. And then sketch the parabola. Start at the vertex and sketch a branch of the hyperbola, approaching the two asymptotes, and then sketch the other branch in the same way. So we're going to start at the vertex, and we're going to approach this asymptote. We're not going to touch it, but we're going to approach it. And like that. This is one branch, and then start at the vertex and draw the other branch. So this is the hyperbola. X squared over 9 minus y squared over 16 equals 1. Okay, so let's do a couple more examples, and then you guys will practice in the homework. So the next example is find the vertices, foci, length of transverse axis, asymptotes, so the same deal. So now our hyperbola is x squared minus 9y squared plus 9 equals 0. So remember, I have to bring it in the form either x squared over a squared minus y squared over b squared equals 1, or the form y squared over a squared minus x squared over b squared equals 1. So these are the two forms that we have. Okay, first of all, it has to be equal to 1, not to 0. So we're going to subtract 9 for both sides first. So it's going to be x squared minus 9y squared equals -9. But I need it to be equal to 1. Either in this form or in that form, it has to be equal to 1. So how do I make -9 a 1? I'm going to divide by -9 both sides. So I'm going to get negative x squared over 9, because it's x squared divided by -9. And then -9 divided by -9 is going to give me positive y squared over 1, because 9 divided by 9 is 1, equals 1. So notice now that I have y squared over 1 minus x squared over 9 equals 1. So which type of the hyperbola we have? The x squared is with the negative, right? It's the y that has the positive. So now it's going to be of type 2, where the vertices are on the y-axis, because y has the positive, okay? So it's of this type. So I can even sketch so that I don't forget. It's going to be like this, opening up branch and opening down branch. Okay, so I know how it looks, but to get it exactly how, like a better representation of it, I'm going to find all these other things and then get the graph. So let's find the vertices. So first of all, what's my A and what's my B? Well, A is the coefficient, A comes with Y and B comes with X in this case. So A is 1 because A comes with Y, and B is 3 because 3 squared is 9. Okay, so then recall that the vertices are on the y-axis now. So the A's represents y-intercept now. So the vertices are the y-intercepts. And they happen at, they're going to be points on the y-axis, so they have the coordinates 0 plus or minus a, which is 0 plus or minus 1. And this is stuff that is listed in here as well. So we found the vertices. Now the foci are going to happen on the y as well, right? They are right here, this first one and the second one. So the foci are going to be 0 plus or minus c. So if I find c, I get the two foci. So recall c squared equals a squared plus b squared. So then c squared equals 1 squared plus 3 squared. So c squared equals 10. So c is going to be plus or minus square root of 10, but we're going to look at the positive one. So this is c. So the foci are going to happen at 0 plus or minus square root of 10. And square root of 10 is 3 point something. Okay, what is the length of the transverse axis? The transverse axis is going to be this horizontal distance or vertical length, and it's going to be 2 times a. So the transverse axis equals 2 times a equals 2 times 1, which is equal to 2. And then the asymptotes in this case are y equals plus or minus a over bx. Plus or minus a over b. So they're going to be a equals plus or minus 1/3 x. Alright, so then let's sketch its graph. First of all, the steps are going to be sketch the central box. Again, the central box is your a, which is a is 1, -1, and then your b is 3. 1, 2, 3, 1, 2, 3. So this is my central box now. And then draw the diagonals of it and extend them, and that's going to give us the asymptotes. And then, so we did sketch the asymptotes. Plot the vertices. The vertices are plus 0 plus or minus 1, so they're going to be here and there. And then finally sketch the hyperbola by starting at the vertex. And we know that it opens up and down, so it's going to be like that. Start at the vertex and hug the asymptotes. So this is the hyperbola. Okay, so let's do one more example. Find the equation and the foci of the hyperbola that has these vertices and these asymptotes, and then sketch the graph. So, first of all, we got to decide what type is this hyperbola we're looking for. Is it of this type, type 1 or type 2? So the vertices are 0 plus or minus 2. So are the vertices on the x-axis or on the y-axis? Well, the x-coordinate is 0 and the y-coordinate is plus or minus 2. So we're going to be in this case. So we're going to have to find the equation of a hyperbola that is like this. So the equation that we're looking for is of this type. So find the equation. So we know that it's going to be at this type. So we need to find a and b, and then we're done. Except we have to also give the foci. Alright, so let's do that, and then that will be it. So I know that the vertices are 0 plus or minus 2, so that means that a is 2, because the vertices happen at 0 plus or minus a. So a is 2, and then what about from in here? I have that y equals plus or minus 2x, and that's the horizontal asymptote. So what is the equation of the horizontal, not the horizontal asymptote, the asymptotes, sorry. So y equals plus or minus a over b. So y equals plus or minus a over bx. So I'm given that the asymptotes are plus or minus 2x. So that means that a over b has to be 2. A over b has to be 2. But I know that a is 2, so then that means that 2 over b has to be 2. And solving for b, we get that b equals 1. So they gave you enough piece of information to solve for what you need. From the fact that the vertices are 0 plus or minus 2, we got that a equals 2. From the fact that the asymptotes are plus or minus 2, we got that b is 1. So I can write the equation now. So it's going to be y squared over a is 2, so 2 squared, minus x squared over b is 1. 1 squared equals 1. So the equation is y squared over 4 minus x squared equals 1. Now to find the foci are going to be the 0 plus or minus c, right? Because the foci are also on the y-axis. They're going to be somewhere here and then somewhere there. So we just need to find c. So we're going to use the fact that c squared equals a squared plus b squared. So that's going to give me c squared equals 4 plus 1. So c equals square root of 5. So the foci are going to happen at 0 plus or minus square root of 5. And square root of 5 is 2 point something. So let's graph it and then we will be done. Alright, so to graph, again the same deal. I'm going to start with the central box. So a is 2, so 1, 2, negative 2, 2, and b is 1, 1, negative 1. I'm going to draw the central box, and then I'm going to draw the asymptotes, which are the diagonals extended. And then I'm going to plot the vertices. The vertices happen at 0 plus or minus 2, so here and there. And then starting on the vertex, I'm going to draw one branch of it hugging the asymptote, and then the other branch of it below. Alright, so that is it about hyperbolas. So it basically comes down to knowing these two equations and the graph. So when the x squared term is positive, that's where you're going to have the vertices and the foci on the x-axis. If the y squared has the positive coefficient, then the vertices and the foci are going to be on the y-axis. And then you need to remember basically the asymptotes and how to get the foci if you have a and b.